Y'all, today we're going to get away from some of these proofs and verifying and just use a couple of properties and use them to solve problems. Okay, so we're going to apply properties of similar triangles today. There'll be a few that we'll go through that you guys will have to know. And again, we'll use them to crunch some numbers and set up some proportions. Okay, so our first one is your triangle proportionality theorem. And it basically says if a line parallel to the side of a triangle, if a line parallel to the side of a triangle intersects the other two sides, okay, so basically it pierces through those two sides, then it divides the sides proportionally, all right? So basically it shows these guys are parallel. Then I know that AE over EB equals AF over AC. They're going to simplify to the same fraction. So if you look at this problem right here, it wants me to find CY. Well, it tells me that these lines are parallel. Therefore, I know that these two pieces are going to be proportionate. Okay, so 9 over 4 is going to be proportionate to 10 over x. You can do your cross multiplying, and you get 9x equals 40, and x equals 40 over 9. You can just leave it as an improper fraction. Simplify it if you can. Okay? So side over side equals side over side. So now you have your converse, which basically says the opposite. If I have a line piercing through two sides of a triangle and AE over EB, or one piece of the side over the other piece of the side, equals the opposite over the other opposite, then those lines are going to be parallel. So take a second and write this down, do your drawing. And we want to verify that the segments are parallel. Okay, so for this verification, guys, all you need to do is show that they simplify to the same proportion. Okay, so we're basically asking ourselves, is MN parallel to segment KL? Question mark. All right, so does 42 over 21 simplify to the same ratio as 15 over 30? Well, they both simplify to 2 over 1. Therefore, I can conclude that segment MN is parallel to segment KL by the converse of the triangle proportionality theorem. Okay? I would want you guys to write this up, but this is enough just to show that that is true. Okay? Or show they're parallel. So we have one more to get through, guys. Actually, we have two more to get through. We have this two transversal proportionality here. And this looks a little liney, but basically all it's saying, if three or more parallel lines intersect two transversals, okay, here are your parallel lines right here, and they intersect two transversals, then they divide the transversals proportionately. Okay, so it's pretty, it looks kind of similar to what you had on the previous slide. This over this is going to equal that over that. The thing that's tricky about these, you just kind of have to keep your head straight on what segment over what segment equals which segment over which segment. Okay? So let's take a second and look at this problem. So an artist used perspective to draw guidelines to help her sketch a row of parallel trees. Okay, it's telling you that the trees are parallel, so these guys are all parallel to each other. And we want to figure out what LN is. Okay, so we're looking for that piece of information right there. Okay, why don't we call that guy X? Well, I know that because these are parallel, this over this is going to equal this over this. However, I don't know what this is. And I also know that this over this is going to equal this over this. Okay, I also have a big, huge segment that I can use. So I can figure out this over this is going to give me this piece over this piece. So you kind of have to play with the puzzle there a little bit. Well, this together adds up to be 3.6. So here I'm ignoring this, and I'm looking at this chunk over this chunk is this chunk over this chunk. And that's the proportion I'm going to use, guys. All right? So 3.6 over 2.4 is going to give me X over 2.6. Cross multiply, and you get X is 3.9. 3.9 centimeters. last one that we'll go over is going to be your angle bisector theorem. Okay? And so the angle bisector, remember guys, bisector, it cuts it in half, of a triangle divides the opposite side, this is your opposite side, into two segments that are proportional to the lengths of the other two sides. Alright? So it tells me it's an angle bisector because it uses your congruency mark, so you know you're going to use this theorem. Let's see what it is talking about here. Left over right is proportionate to left over right. That's how I think about it when I'm setting these problems up. Left over right is proportionate to left over right. Okay, so let's see if that helps us when we get down here to our example. We want to find RV and VT. Okay, so here's your RV and your VT. We're solving for X. So it's telling me that it's an angle bisector, so I'm going to use my angle bisector theorem. So I know that left over, or excuse me, we'll say bottom over top is going to equal bottom over top. Okay? Bottom over top is going to equal bottom over top. Just take a second and process that and make sure you see the pattern. Cross multiply, make sure you distribute. So you get 20x plus 20 is going to equal 14x plus 28. Solve for x, you get 6x equals 18. And then x is going to be 3. What's the question asking, guys? Be careful. Don't stop here and circle A is 3. We want to find RV. Okay, so RV is going to be 3 plus 2, which is going to be 5. And then we also want to find VT. Okay, so the length of VT is going to be 2 times 3 plus 1, which is going to be 7. So that's all we got. Nice, quick, easy section compared to some of that heavier stuff we did last week, so enjoy it. We'll work on this in class tomorrow, guys, and recap.